Two masses M1 and M2 are attached to a spring balance S as shown in figure. If M1 greater than M2, then the reading of spring balance will be. So reading of spring balance means that there is a spring actually present in the spring balance. So the tension in here is going to be the reading inside the spring balance. If you draw the free body diagrams of both the blocks, here you have what? Tension T1, contact with gravity, you have M1g. Because M1 is greater than M2, let's say the acceleration is downwards. In here you have T2, contact with gravity, the mg downwards. Because this particular block is moving downwards, this particular block will be moving upwards. I'm writing the equation for the spring balance. Here you have T1, this direction you have T2. So T1 minus T2 equals to M into A, because spring is massless. So T1 equals to T2. So this T1 equals to T, let's say T2 equals to T. Now write the equations. M1g minus T equals to M1 into A. The other equation is T minus M2g equals to M2 into A. So G into, if you add both the equations, G into M1 minus M2 equals to A into M1 plus M2. So acceleration equals to G into M1 minus M2 by M1 plus M2. So substitute the value of A in any of the equations, 1 or 2. So then you will get M1g minus T equals to M1 into A. A is what? G into M1 minus M2 by M1 plus M2. So now if you solve that, you will get what? T equals to 2 M1 M2g by M1 plus M2. And this is your answer, because he is asking reading in spring balance, that is tension present in the spring of the spring balance. So option 3 is the answer.